This video is sponsored by Penn State University's Architectural Engineering program. Civil engineering is arguably one of the oldest engineering disciplines in the book, and it started the first time that someone created a shelter over their family or used a tree trunk to cross a river. And now, civil engineering permeates into all facets of human society. Every building that we live and operate in, all of the transportation networks that we use to get around, the air quality, the water quality, environmental systems in general, including protection of the environment, as well as the subsurface systems, all the pipes and utilities and tunnels and everything that is a foundation for the infrastructure that we live and operate on is handled by civil engineers. It's an incredibly broad field. You can work in any sector and industry that you like. So in this video, we're going over the top 9 best occupations within civil engineering, and we're starting right now. On this channel, I talk about tips for engineers, college, and career advice. So if this is you, make sure you hit the notification bell and subscribe. Leave a like to help this video defeat the YouTube algorithm. The salaries in this video reflect the base median salaries of civil engineers that were surveyed by the ASCE's 2019 salary survey report. And we're starting off with job type number 1, which is structural engineering. We're starting here because structural engineering is without question the primary focus and absolute foundation within civil engineering. Structural engineers calculate, test, design, analyze, modify, redesign, and continue to estimate and calculate things within any sort of structural engineering realm, down to a small individual structure or a larger complex one. They work with a variety of structural types, including buildings and bridges, which are the most common, but these engineers also may design towers, tunnels, dams, railway facilities, waterways, reservoirs, power stations, and even offshore structures like oil rigs. Some structural engineers have unique careers that enable them to work with the structural analysis and design of things like big ships and large aircraft, and even things like satellites and the International Space Station. Their work takes into account mainly safety, technical, economic, and environmental concerns, but they also consider aesthetics and social factors. The difference between structural engineering and architecture is that architects are more concerned with these aesthetic features, with the integration with other buildings and the built environment, and all of the social ramifications that are included within a design or project. Structural engineers ensure that all buildings are strong enough and capable enough to handle all of the loads that may be present on that structure. For example, these may include gravity, wind, snow, rain, seismic loads, earth pressure, temperature, and traffic loads in order to prevent or reduce the loss of life or injury. They also design structures not to vibrate enough to deflect beyond acceptable limits. Human comfort is an element that is regularly considered within the limits of structural engineering. Design fatigue is also an important consideration for bridges and aircraft design or for other structures that experience many stress cycles over their lifetimes. Not only is structural engineering the primary foundational element within all of civil engineering, it is commonly considered its own discipline within its own right. In the United States, most practicing structural engineers are currently licensed as civil engineers, but the situation varies from state to state. Some states have a separate license for structural engineers, which is required to design special buildings like skyscrapers, or with locations out west with earthquake design being a concern, hurricane considerations down south, and so on. There's a lot of jobs available for structural engineers. It has a median base salary of nothing too flashy at $100,000. The median of all civil engineers by the Bureau of Labor Statistics is $87,000, so not too bad. And because there's so much flexibility and opportunity in this field, this is an A-tier job option. Next up, we have utilities engineering. Utilities engineering focuses on the planning, position, design, construction, operation, maintenance, and asset management of any and all utility systems, as well as the interaction between utility infrastructure and other civil infrastructure. There are a variety of types of utilities out there, including power, water, steam, gas, sewer, storm, and more. These engineers work to improve the way utility services are delivered to homes and businesses, often engaging in public works projects that provide new service to communities and work to improve existing services with updated technology and best practices. During situations that cause outages or loss of services, these engineers help to direct and manage work crews that restore the utilities in as fast and safe a manner as possible. Utilities engineers manage certain risks associated with utility mapping at appropriate quality levels. Utility coordination, utility relocation design and coordination, utility condition assessment, communication of data for concerned parties, relocation and estimates, implementation of utility accommodating policies, and utility design. Utility engineers might design plans and operations for utility systems. They may identify and resolve system failures, perform and oversee preventative maintenance, direct project groups and or technicians, providing activities and guidance within the utilities process, and various other tasks that have to do with the protection of existing systems or the maintenance of the system. Utilities engineers make a considerable amount more than a lot of other engineering types. You may be surprised because this is not talked about enough. There are a decent bit of jobs out there. There's about 10,000 openings on Glassdoor right now, and with a median salary of $118,000, you can pretty much work wherever you want all over the country. Everywhere has utilities, and because of these reasons, this is an S-tier job option for civil engineers. Okay, next up we have architectural engineering, and this message is brought to you by our sponsor, Penn State University and their architectural engineering department. Architectural engineers apply practical and theoretical knowledge to the engineering design of buildings and building systems. The goal is to engineer high-performance buildings that are sustainable, resilient, economically viable, that ensure the safety, health, comfort, and productivity of occupants. Uniting scientific principles from structural, mechanical, electrical, lighting, acoustical, and construction engineering, architectural engineers apply their discipline-specific expertise to conceptualize, design, construct, operate, and maintain built environments in interdisciplinary team scenarios. Graduates of architectural engineering are widely considered to be creative systems engineers with formal training in creativity and design through architectural design studios married with a solid engineering education. The employment opportunities for architectural engineering are endless, and they regularly accept job offers from architectural engineering firms, consulting engineering firms, real estate developers, building equipment designers, manufacturers, designers and producers of building materials and products, facilities engineering and management groups, and beyond. You might like architectural engineering if you have an aptitude for math and science, have an appreciation for the artistic and emotive aspects of buildings. You are fascinated and passionate about design and construction, about sustainability, climate change, and building-related illnesses like asthma. You like to organize parts of a system or process and solve problems that help others. Penn State's program features 4 varying disciplines: construction, structural, lighting/electrical, and mechanical. Because the ASCE salary report features both structural and construction engineering as options, architectural engineering graduates from Penn State can go into these career paths as well. Why do I support Penn State University's architectural engineering program? There's plenty of reasons. First of all, they've had nearly a 100% job placement rate for 30 years for their graduates. They're home to the largest architectural career fair in the world, where 135 companies come every single year to attend, and they have 60 more companies that are on the waiting list. They have the lowest unemployment rate of engineering majors by a USA Today poll at 1.49%. They offer a bachelor's program, of course, but also a master's degree program with just 1 extra year, where 93% of those students graduate on time within 5 years. Half the Penn State students study abroad at places like Rome or China. 90% of their students obtain internships. And finally, they have an opportunity to compete in the AEI Student Design Competition, where in 2009, Penn State swept the entire competition and won every single first place prize. Last year, 2020, they got 3 top place and 3 second place. Pretty good. Learn more at ae.psu.edu. The median salary for architectural engineers is $101,000, and with such a low unemployment rate, plenty of job flexibility, and a lot of growth going forward, this is an A-tier job option for civil engineers. Okay, next up, geotechnical engineering. From a scientific perspective, geotechnical engineering largely involves defining the soil strength and deformation properties. Clay, silt, sand, rock, and snow are important materials in geotechnical engineering. This type of engineering includes specialist fields such as soil and rock mechanics, geophysics, hydrogeology, and associated disciplines such as geology. Geotechnical engineering uses scientific methods and principles of engineering to collect and interpret the physical properties of the ground for use in building and construction. Its practical application, or foundation engineering, has come to require a scientific approach. The term geotechnics is sometimes used to describe both the theoretical and practical applications of the discipline. Geotechnics is applied when planning infrastructure such as roads and tunnels, as well as buildings and other construction onshore and offshore. The discipline also involves performing numerical calculations, analyzing the stability of slopes and cliffs, assessing load-bearing capacity, and settlement and deformation in man-made structures. Research and development in geotechnical engineering is carried out to improve and further refine equipment and methods for carrying out ground surveys. Geotechnical engineers may work with equipment and methods for surveying and testing sediment and rock samples in a laboratory. They may work with methods for calculating and analyzing the behavior of bearing capacity of soil and rock when planning structures, offshore installations, tunnels, and subterranean spaces. And they may also work with methods of measuring, instrumenting, and subsequently documenting whether buildings and other structures behave the way they were designed to. We have all seen geotechnical engineering failures. The most notable is probably the Leaning Tower of Pisa, along with Riverside Block number 7 in Shanghai, where the entire building just fell right over because of a foundational failure. Check out the sinkhole in Guatemala City, along with plenty other leaning towers that are more modern to our world, like the Millennium Tower in San Francisco. Big Ben in London was actually leaning. The two towers of Bologna, the Tiger Hill Pagoda, and the Church of St. Mary and All Saints. Plenty of leaning structures even to this day. Geotechnical engineering is one of the more complicated types of engineering. One of my professors in university always talked about how you can do as many samples as you want, collect as much data as you possibly can with all of your budget, and you still can easily make mistakes because you just can't tell what's going on under there. It's a pretty exciting field. It is decently niche though, because the salary is just $100,000 medium, and I can only find 4,800 positions on Glassdoor right now. This is going to have to be a B-tier job option for civil engineers. Okay, number 5 is environmental engineering. Environmental engineers use the principles of biology and chemistry to develop solutions to environmental problems. They are involved in water and air pollution control, recycling, waste disposal, and public health issues. Environmental engineers conduct hazardous waste management studies in which they evaluate the significance of that hazard, advise on its treatment and containment, and develop regulations to prevent mishaps. They design municipal water supply and industrial wastewater treatment systems, conduct research on the environmental impact of proposed construction projects, analyze scientific data, and perform quality control checks. Environmental engineers are concerned with local as well as worldwide issues. Some may study and attempt to minimize the effects of acid rain, global warming, automotive emissions, and ozone depletion. They also may be involved in the protection of wildlife. Many environmental engineers work as consultants, helping their clients to comply with regulations, prevent environmental damage, and clean up hazardous sites. Environmental engineers typically do the following: prepare, review, and update environmental investigation reports, design projects that lead to environmental protection, such as water reclamation facilities or air pollution control systems. They may obtain, update, and maintain plans, permits, and standard operating procedures, provide technical support for environmental remediation projects for legal actions, analyze solutions to the data that they capture, and more. There are 55,000 jobs existing for environmental engineers. The Bureau of Labor Statistics actually reports on this field in its own right. Its median salary is $109,000, which is pretty good. It's super flexible. You can work anywhere. It's going to be growing in the future because we have done a lot of environmental damage to this planet. Because of these reasons, this is an A-tier job option. Okay, next up we have my industry, which is transportation engineering. Transportation engineering is the application of technology and scientific principles to the design, operation, planning, and management of transportation infrastructure, mobility service, traffic, and travelers for various travel modes. A travel mode is something like car, rail, transit, air, seaway, things like that, in order to provide for the safe, efficient, rapid, comfortable, convenient, economical, and environmentally sustainable movement of people and goods. Transportation engineering is super broad and involves all of the various fields, including highway design, urban planning, travel demand modeling, intelligent transportation systems, public transit, seaports, airports, railroad engineering, traffic engineering, user safety, pedestrian facilities, freight, pavement engineering, pipelines, and more. As a civil engineer in university, I focused on transportation engineering because of its connection to technology. I was writing papers on driverless vehicles back then. We could already see the future of connected vehicles and vehicle to infrastructure communications. And everybody knew that because of sci-fi, that cars would be flying and we would have drones delivering packages one day. And this was one of the coolest things for me within transportation engineering, so I pursued that field. I ended up working in ITS, Intelligent Transportation Systems, and spent most of my career doing travel demand modeling, where we would win a study within a large infrastructure project, usually a multi-billion-dollar bridge, and we would have to forecast what the 50-year horizon would look like and choose the best alternative of this bridge. It's a super cool field. As you can see, connected to tech, you can work in all types of sectors and in any city all across the world. Because of its attachment to tech, you can use a lot of programming skills, and there's so many jobs out there. It's really exciting. The median salary is not that bad at $106,000. And for these reasons, this is an S-tier job option for civil engineers. Okay, number 7 is general civil engineering, or as some people would call it, a municipal engineer or public works engineer. General civil engineers plan, design, supervise the construction of, operate, maintain, inspect, and manage many of the physical facilities and systems in both public and private sectors. These facilities include buildings, commercial facilities, industrial facilities, power transmission facilities, transportation, tunnel, water collection facilities, water treatment, and waste disposal facilities. General civil engineers are often responsible for site design, which may include grading, facility location studies, utility design, environmental compliance issues, code enforcement, public decision-making, and project management issues. Some general civil engineers also become registered professional land surveyors and are engaged in land surveying as well as civil engineering professional activities. As such, general civil engineers must have a broad base on their education and knowledge around civil engineering specialties. Engineers who work in general civil engineering are often employed by areas such as land development, public works, and even military engineering. They may end up working for a city, a county, a state agency, a federal agency, a utility company, and various other industries. A general civil engineer is a person who has a strong foundation for choosing any other specialty within engineering that they may choose. And a lot of general civil engineers go on to grad school after a few years if they want to galvanize their skills. It's hard for me to get excited about a general civil engineering job, especially those that are in the public sector, which again means you might work for a government or a state body or a county agency where you're not going to have as much salary, which is reflected here with a median of $100,000 a year. Because it's too general, it's not too flashy, this is a B-tier job option. Next up, number 8, we have water engineering. There are two disciplines within water engineering. You have water resources engineering and hydraulic engineering. Water resources engineering is the quantitative study of the hydrologic cycle, the distribution and circulation of water linking the Earth's atmosphere, land, and oceans. Subsurface runoff is measured as the difference between precipitation and abstractions, such as infiltration, which replenishes groundwater flow, surface storage, and evaporation. Applications include the management of the urban water supply, the design of urban storm sewer systems, and flood forecasting. The other form of water engineering, as stated, is hydraulic engineering, which consists of the application of fluid mechanics to water flowing in an isolated environment, such as a pipe or a pump, or in an open channel, such as a river, lake, or ocean. Civil engineers are primarily concerned with open channel flow, which is governed by the interaction between water and the channel. Applications include the design of hydraulic structures, such as sewage conduits, dams, and breakwaters, and management of waterways, such as erosion protection and flood protection, and environmental management, such as the prediction of the mixing and transport of pollutants in surface water. Hydroelectric power development, water supply, irrigation, and navigation are some familiar applications of water resources engineering and may involve the utilization of water for beneficial purposes. Water engineers make a median salary, again, of $100,000, a pretty common type of salary on this list. And because a lot of water engineering roles are connected to environmental engineering, there's a whole lot of jobs out there. So despite a not so flashy salary, this is an A-tier job option. Okay, last and certainly not least on this list, which is the highest salary that we have to offer, which is construction engineering. Construction engineering concerns the planning and management of the construction of structures such as highways, bridges, airports, railroads, buildings, dams, and reservoirs. Construction of such projects requires knowledge of engineering and management principles and business procedures, economics, and human behavior. Construction engineers engage in the design of structures temporarily, cost estimating, planning and scheduling, materials procurement, selection of equipment, and cost control. Construction engineering is differentiated from construction management from the standpoint of the use of mathematics, science, and engineering to analyze problems and design a construction process. A good familiarity with reading blueprints is necessary because construction engineers build many of the things that people use every day. Construction engineering involves many aspects of construction, including commercial, residential, bridges, airports, tunnels, and dams. It is an extremely large large industry that provides jobs to many and continues to grow. Construction engineers are in high demand, so it's easy for a civil engineer to get a job in most of the country. Here are some of the tasks that they may work on, which includes analyzing reports, maps, drawings, blueprints, and aerial photography, and other topographic information. They may monitor costs and estimate calculations, monitor budgets and schedules. They could communicate with contractors, construction staff, or other engineers. They might use software to design systems and structures while following construction codes. They have to calculate load and grade requirements, liquid flow rates, material stress points. They have to monitor the site safety, monitor site cleanliness. They might have to look at survey data and document inspection and more. Construction engineering is a unique field where you might have to travel. It's pretty long hours and it's sometimes high pressure and intense work. And that's why the salary for construction engineers is the highest on this list at $119,000 for a base median salary. It can be pretty exciting. You're always working on something that's connected to the local area, and oftentimes you're working with big projects, with big budgets, with big pressure and big salaries to come with it. So if you can handle the heat and you want to work in a cool industry, I encourage you to check out construction engineering. And because of all these reasons, this is an S-tier job option for civil engineers. What do you guys think of the 9 jobs listed here for civil engineers? Comment below. I respond to every comment nowadays. So if you have a question about civil engineering or any type of engineering, career or student question, drop it in the comments and you will hear from me. Leave a like on this video to defeat the YouTube algorithm. If you're an engineer or someone looking for college or career advice, make sure you hit the notification bell and subscribe. Check out our other videos. We have over 140 episodes of this show, and we'll see you again in another video. Bye-bye.